Okay, lesson 55 is about circular permutations and distinguishable permutations. First of all, I messed this little part up, so you need to change these letters on this third line to P, K, and Q. So what we have are three possible ways that you could line up three people. All right, if you had the king, the queen, and the prince in a line, you could put the king, then the queen, then the prince. Or you could put the queen, the prince, and the king. Or you could put the prince, the king, and the queen. Now, these, when you put them in a line, they all look different. But if you imagine that you have a room that's a circle, and in the middle of the room there's a circular table, and there are no distinguishing marks here, and you were to put these people in this order around the table, then you can see that all three of these really are the same. King, queen, prince, queen, prince, king, prince, king, queen. The one circular permutation is the same as these three because all we did is change who was first in line. The king is always to the queen's right hand, and the prince is always to the left of the queen in all of those situations if you put it into a circle. So this permutation, we don't want to count it 3 times if we're talking about just circular permutations. We're talking about placing people in a circle now. So when we talk about circular permutations, if we have 3 things, if we're talking about linear permutations, it's 3 factorial. How many ways you can place 3 people in a row, and there are more than this. But when we talk about circular permutations, what we do is we divide out the ways that somebody can be first. So we would divide out, there are 3 people, so there are 3 ways somebody could be first for every single permutation that we do. So we divide that out and it becomes 2 factorial. So circular permutations, there are fewer of them than linear because you divide out all the ways that somebody can be first, because in a circle it doesn't matter who's first because there is no first. Okay, so let's just look at it a little more clearly. Here I've got those 3 tables. So you can see that all 3 of those permutations are the same. Like I said, if we have 3 items, there are 3 factorial linear permutations. There they are. 3 times 2 times 1. That's 6 different ways. But there are only 2 circular permutations because there's really only 2 ways you can seat these people at a table where there's any difference. Here we've got the prince, the king, and the queen. The king is to the prince's left and the queen is to the prince's right. Here we've got the prince, and now the queen is at his left and the king is at his right. Those are really the only 2 ways you can place those 3 people at a table that's any different. All the others are exactly the same, all these other ways, because it doesn't matter who's first. So we find that the number of linear permutations of n items is n factorial, but the number of circular permutations of n items is n minus 1 factorial. So if we ask how many ways can 6 different items be arranged in a line, that's 6 factorial. 6 times 5 times 4 times 3 times 2 times 1, which is 30 times 4, which is 120, 360, 720. And the number of ways that they can be arranged in a circle is 6 minus 1 factorial, or 5 factorial, which would just be 5 times 4 times 3 times 2 times 1, which would be 20 times 3, which would be 60 times 2 is 120. All right, when the chips were down, Emma found that there were 5 chips and each one was a different color. How many ways could Emma place them in a row? 5 factorial in a row, 120 ways. But for a circle, you have to subtract 1 because you're subtracting out all the ways that somebody can be first. So that's 4 factorial, which is 4 times 3 times 2 times 1, which is 12 times 2, which is 24 ways. So just remember, circular permutations, it's n minus 1 factorial. Linear permutations, it's n factorial. If n is the number of things, the number of different things that you are arranging, either in a line or a circle.